All right, students, today we are going to begin our transformations unit, and we're going to start with translating figures and using vectors. We're going to go through a couple of vocabulary terms, and we're going to start with the pictures. All right, first you'll see a triangle. This is an arrow pointing to this triangle over here. This is your original triangle because it has solid lines. It's going from this triangle and it's being transformed into this one. I put a star on the one that we're talking about. So here it says, a new figure produced from the transformation of a figure. So the star is representing the vocabulary word. All right, so this new figure we call the image. And so here I show it in pink. Next we have the original figure in the transformation of a figure. So here the star is on the original figure. That one we call the pre-image. Okay, and so this one here, I'm talking about the one with the red star. And that's, again, this is the original as we transform over to this one. So it's talking about this transformation. All right, next, a transformation that preserves the dimensions of the figure. So if you look, you've got this one here, and it's being transformed to this one. But if you notice, and this one up here is supposed to be dotted, but you can't tell because the dots are too small. So I'm going to go back in and highlight this. This right here is supposed to be dotted to represent the change figure. So here, when we transform a figure and it doesn't change the dimensions, we call that isometry. Right, so isometry. All right, next. This next picture here is of an arrow. And this arrow starts here, and notice how we don't know if this is the first quadrant, second quadrant. We don't have any kind of numbering system to know what point this actually is and what point B is. So we can't find the coordinates of A and B. That's not the point here. It says a quantity that has both direction and magnitude. So here we know where it's going to begin and we know where it's going to end. And we call that a vector. Right? The starting point of a vector, I'm pointing at this one here, A, because here it has a point here, it's like a ray, and it starts here, stops there with the arrow. So the starting point of a vector, we call that the initial point. Right? Again, we've got the same picture here, but in this picture, it's the same ray, A to B, there's the arrow. So I'm talking about this point right here, where it ends, the ending point of the vector. We call that the terminal point. Okay. Next, a component that describes the left and right direction of a vector. Okay, so this picture right here is going to be for both of these vocabulary words. So a component that describes the left and right direction. So if you look here, the left and right, left to right, that's going to be the horizontal component. So here this one here, that's going to be the horizontal component. And that's what I'm going to write over here. Because horizontal moves left to right. Okay, next, we're talking about this here, and that's going to be the vertical component, a component that describes the up and down direction of a vector. That's going to be the vertical. The vertical component. Okay, so that's page 1. Page 2, we have one more vocabulary word. It says a form that combines the horizontal and vertical components. All right, so the form that we're talking about is the component form. All right, so component form. Component form, you have a picture of this vector over here from A to B, and it says that the component form of vector AB is 3, 4. Now, I want you to pay attention to this and highlight it, because these are not parentheses. These are greater than, less than signs, so they actually are like little arrows. And this up here, we'll talk about down here a little bit, but this is it looks like a ray, but it's a special kind of ray. It only has one side of the arrow. Okay, so this is called the component form. This right here in yellow. Component form looks like this. Vectors. The diagram shows a vector named FG. Now look here. You see that arrow? The arrow is drawn from left to right, and then it only has this side of the arrow. It doesn't have the bottom side, so it's not a full arrow. It's like a half arrow. And we read that as vector FG. You always have to start with the initial point when you're naming it to tell someone where it begins. So that's why the F must come first. You cannot put the G first. So the initial point or starting point of this vector is F. Okay, that's F. The terminal point or ending point of this vector is G. All right, here's my vector. The vector looks like an arrow. It's going to go over to the right 5, and then it's going to go up 3. To get from F to G, we have to move 5 units to the right and 3 units up. The component form of the vector combines the horizontal and the vertical components. The component form of FG is, now, you're going to use the greater than and less than signs. So here's the less than sign. And then you're going to put the horizontal movement first. So that's a positive 5 because it's 5 to the right. So 5, comma, and then 3 up. So that's a positive 3, 3, and then close with the greater than symbol. All right, so that looks a little unclear to me, so I'm going to put, this is 5, comma, and that would be a 3. Okay, let's do some examples. The first example says, graph quadrilateral ABCD with these vertices here that are listed. So that's the first thing we're going to do. 2, 6, I'm sorry, it's negative 2, 6. I'm going to put a dot, and I'm going to label A. 2, 4. Put a dot, label B. 2, 1. Put a dot, label it C. Negative 2, 3. That's going to be D. Okay, so here, this is my original, so these are solid lines. I'm going to connect all of my vertices. Find the image of each vertex after the translation. Translation, remember, that's from 8th grade math. It means to slide the figure over. This right here is called transformation notation because here's your original point, and what this is telling you to do is move it, the X, 3 units over to the right, and then the Y tells you up or down, so that's going to say down 3 units. So right 3, down 3. So I'm going to take my A, I'm going to go to the right, 1, 2, 3, and then down, 1, 2, 3. And I'm going to call this A prime. Do the same thing with B, 1, 2, 3, 1, 2, 3. That's B prime. 1, 2, 3, 1, 2, 3. There's your C prime. And D is going to be 1, 2, 3, 1, 2, 3. There's your D prime. This one's going to be dotted because this is the transformed figure. It says then graph, okay, it says find the image of each vertex after this translation, then graph the image using prime notation. This is called prime notation. All right, we need to list the points. The original points are A is -2, 6, B is 2, 4, C is 2, 1, and D is -2, 3. Then we're going to transform it, so we use an arrow, and it changes into A prime. And then we list the new points for A prime. A prime is going to be at 1, 3. B prime is going to be at 5, 1. C prime is going to be at 5, -2. And D prime is going to be at 1, 0. All right, next. We have a theorem here, and our theorem matches our definition. It just says the translation theorem is if you translate a figure, it's isometry. It's not going to change the shape or size. So the dimensions will stay the same. So that just means that here, triangle ABC is congruent to A prime, B prime, C prime. And you can barely tell, but these are primes right here. So you can make those darker if you want. All right, next example. Write a rule for the translation of triangle ABC to triangle A prime, B prime, C prime. Then verify the transformation is isometry. Okay, so here I've got the translation rule. Looks like this. That's X, Y. Then we have an arrow. And it's all you're doing is telling someone, how are you getting from A to A prime? Over here, A up to A prime. This one is the solid one, so this is the original. This is the dotted, so we know that's the image. So I'm going to go up 1, 2, so that I'm going up 2, and then I'm going left 3. Okay, so I always do the right or left first when I'm writing my transformation notation. So that's how am I changing the X? The X is going to be left 3, so that's -3. To the left is minus, to the right is plus. Then comma, up and down changes your Y. So this is going to be up 2, that's going to be plus 2. If I was going down 2, I would say minus 2. So here's my rule, using transformation notation. And then how do you verify? Okay, well, here I know that triangle ABC, this is going to be 1, 2, 3. So I know that AC equals 3 units. And this A prime C prime is also 3 units. A prime C prime is 3 units. Then I've got this one here, that's 2 units, and that's 2 units. So BC equals 2 units. And B prime C prime is 2 units. And then I have, this is, you can tell this is a right angle, because you can see that square there. Those are right angles. So this is congruent to this because of side, angle, side. So triangle ABC is congruent to triangle A prime, B prime, C prime because of side, angle, side. Congruence postulate. All right, next one. Name the vector and write its component form. All right, where's the beginning point? Where's the end point? It begins here at G. It ends here at H. And to use vector notation, it's an arrow with only one of the little arrow marks, not the one on the bottom, just the one on the top. And then the component form is, how do you get from G to H? Okay, so I start off with here, and how do I move left or right? So that's going to be to the right, 1, 2, 3, 4, 5. So that's positive 5, and then down 2. The next one, name the vector and write its component form. Same thing. Starting point, ending point, so that's going to be RS. And then how do I get from R to S? It's moving to the left. 1, 2, 3, 4, 5, 6, 7. So it's going to be minus 7. It doesn't go up or down, so that's going to be 0. And finally, we have the vertices of ABC are listed here. Translate this using this vector. Okay, well, I'm going to first graph my triangle. That's going to be 0, 4. So do not move right or left. Up 4, 1, 2, 3, 4. There's my A. B is at 2, 3. Okay, so there's B. And C is at 1, 0. There's C. All right, so this is my original. So this is solid lines. All right, and then we're going to translate it using this vector. This vector tells me that I need to go left 4 down and up 1. So 1, 2, 3, 4, up 1. There's A prime. 1, 2, 3, 4, up 1. There is B prime. And 1, 2, 3, 4, up 1. There is C prime. And this is going to be dotted because this is the transformed figure. And there you go. That is how you do it using your vectors. The rest of those, the next page is your check for understanding page. You'll have 3 problems on this page to do, and then you have 4 through 11 on this page to do. And you need to make sure you bring that in so we can check it and grade it. That this is going to be how you get your notes graded. And that is it, folks, for notes 9.1.